Good afternoon. Hope you're having another great afternoon and a great day. All right, Chapter 7 test. Big test, 2 days, will be broken up into 2 parts. You will have a calculator part and a no calculator part. The no calculator part is no calculators of any kind part. So just make sure that the ones on here that say no calculator, so you'll come across them in red. If it says no calculator on the review, then there is no calculators on that question. There are 10 questions on the no calculator part. You will find 10 questions on the review with no calculator part next to it. There are 10 questions on the test with a graphing calculator, and you will find 10 questions on the practice or the review here that do not that allow you to use calculators. So basically what I'm saying is every single question that is on the test is on this review, and I have labeled them. The red part that says no calculator is no calculator. The ones that don't have anything are the ones that you will be allowed to use a calculator. There is one problem on the review, problem number 9, that I took off of the test, and I just crossed it off on here so that you knew to skip this problem, not on the test. Okay? So what I'm going to do is just start with number 1 and work through it. You guys can pause or play or move things around, go up to another question if some of you have worked on this ahead of time and want help on number 18. I am going to try my hardest to get this posted on eClassrooms, so you can check the eClassrooms folder. The only thing you might have to do is save you have to click on the file, it'll say video on it, you have to save it to your computer and then you'll be able to play it. You will not be able to play it from the eClassrooms folder. So save it to the desktop, then play it. If you have issues or questions, please, please, please email me, leave me a number, and I will get back to you. Okay, so let's go ahead and get started. The first one says, tell whether this is an exponential growth or decay, and then graph the function. So remember, the formula that we need is AB to the x. So we need to look at this value to determine if it's an exponential growth or an exponential decay. And since that value is bigger than 1, we know that it is an exponential growth. So we know right off the bat it's an exponential growth. Okay? Now, when you graph this, a couple things are going to be very important that I am looking for. A, do you know it's a growth? B, where is the y-intercept? So in this case, remember that the y-intercept is always going to be this A value. So your y-intercept is at 7/8. So you're going to place your y-intercept about right there. Okay? Now, if you wanted to throw this in your calculator, since you will be allowed to use your calculator, remember this is from yesterday, I need to turn my plot off because I'm not using the plots anymore. Clear out everything in here. And I can just type in 7/8 times 1.1 raised to the x power. All right, and I'm going to do a zoom 6 because that's a standard window. And then if you want to look at your table, remember you can go second table, and we can look at our table. So we can see out here at -3, it's pretty small, 0.6. And then it gets a little bigger, and a little bigger, and a little bigger. And then at 1, it's 0.9. And then at 2, it is 1.0. 3, it's 1.1. So you can see it's going up pretty slowly. What's extremely, extremely important is that you show me, that you recognize that there is an asymptote on that x-axis. It crosses at y = 0. So I need to know, if you want to come in and put dotted line here to show that you have an asymptote, that's great. But this line cannot come down underneath here. Okay? Don't forget, too, to look at your quiz over the first part of this chapter. That might be another good study guide. All right, problem number 2. It says Gina buys a car for $13,500. Assume that the value will decrease by about 15% per year. Write an exponential function. So it's telling you exponential function to model the value of this car. Graph the function, and when will it be below 3,000? Well, remember our formula was A of t, and I will not give you this, equals A times 1 plus or minus the rate, depending on if it's a increase or a decrease, all to the t value. So this formula would be a sub t, our final amount, is equal to our initial amount, which was 13,500, times 1, and then since this is decreasing, we are going to subtract our rate, and you have to remember to put this as a decimal. Sometimes this is the biggest mistake you guys make, is converting 15% to a decimal. It's 0.15 to the t or x power. I will accept one of two equations. I'll accept this equation, and I'll also accept, if you want to go ahead and subtract that value, you get 13,500 times 0.85 to the t or x power. Okay? So there's your model. So it says write an exponential model. Either one of these answers would be acceptable. Okay, graph the function. So I'm going to go to my graphing calculator, clear everything out here, and I'm going to type in 13,500 times 0.85, close those parentheses, raise it to the x. Now, if I do a zoom 6, I may not see anything, because what's your y-intercept? Where is this graph starting before it decreases? Your y-intercept is at 13,500. So on our window, we need to change this to maybe 14,000. So I'm going to change my y max to 14,000. And I'm going to go by a scale of 2,000. And now I'm going to graph it. Okay, now it says, when will the value drop below, sorry, did not draw that straight line right. When will the value drop below 3,000? So what you're going to do now is you're going to go back to your graphing. I guess we need to think, is that the final amount or is that x? Well, that's the final amount, so that's y. So they're saying, when is y going to drop below $3,000? So again, we can go to our calculator, and we can type in 3,000 for y2. Graph it. We are seeing this point of intersection, which is good, so our window is fine. We can just do second, calc, intersect. Is that the first curve? Yes. Is that the second curve? Yes. Do you want it to guess? Yes. There's only one point, and it is right here. So we know that this will drop below 3,000 in 9.25 years. 9.25 years. Okay? All right, problem number 3 is a no calculator part. It says write the inverse of this function. Well, remember that f of x is the same as y, so the given function is y equals 5x minus 7. Remember, recall that to write the inverse function, you're going to just switch x and y. So you get x equals 5y minus 7. And we need to solve this for y, and this is a no calculator problem. So to solve it for y, we're going to add 7 over. So we get x plus 7 equals 5y. And one of the things that I was surprised on the quiz you guys missed a lot of, remember when you divide, you need to divide each piece by 5. So you get 1/5 x plus 7/5 equals y, or remember the inverse is f negative 1 of x. So your inverse function is 1/5 x plus 7/5, and there's your inverse. Okay, moving forward, number 4, write in log form. All of these are no calculator. Okay, so remember the log form, this is pretty easy. We can just swoop. We can say log base 16 of 2 is equal to 1/4. And we're done. So there's your log form. Write an exponential form. Well, again, we're going to swoop. So 1/4. And this 1/4 should be in parentheses, so I know that both of these things are being raised to the negative 3rd power is equal to 64. 1/4 to the negative 3rd equals 64. Okay? Done. Okay. Problem number 6 says write as a single log. So there will be 2 answer blanks on your test on this. It'll have a line for the single log and a line for the simplification, and there are no calculators on this part. Okay, so remember our rule to subtract. To subtract logs, oops, hang on a second here. To subtract logs means that we are going to divide. So we are going to divide 128, okay, 128 by 8. Now some of you I know are thinking, oh, she's not letting me use a calculator on this. We picked numbers that are a little more friendly, even though as honors students I think that that's not out of your range. And this is log base 4. So we have log base 4, and then you always take 128 divided by 8. So if you divide 128 by 8, you get 16. So you have the log base 4 of 16. There's the single log. Now it says simplify. So to simplify, you say, what is this equal to? So remember, you have to ask yourself the question, 4 to the what power is 16? 4 to the what power is 16? Well, hopefully you all remember or know that that is 2. So the answer to log base 4 of 16 is the number 2. All right, again, express as a single logarithm. We have log base 3 of 243 to the second. Whenever we have this 2 out here, remember you bring it out front. The rule said log base b of a to the p power is equal to p times log base b of a. Okay, so you're going to bring this 2 out, so you get 2 times the log base 3 of 243. So here's your first answer, expressed as a product. So there will be 2 answer blanks. Here's 1. Now the second part says, what is this equal to? So once again, you have this 2 out here, but this part you need to ask yourself, 3 to the what equals 243. So you kind of come off to the side and think, 3 to the what power equals 243. Again, we pick numbers that are a little kinder for you on the test, but 3 to the what power is 243. Some of you may know it's 5. So now we have 2 times, and the value of log base 3 of 243 was 5, and 2 times 5 is 10. And we're done. Okay, next one, evaluate. Now this is a calculator problem, and sometimes you guys have been cruising so long and you kind of forget this, so be careful on this. Don't let this one get you. This is an easy problem. This one follows the change of base formula. If you have log base b of m, remember it's equal to the log of m divided by the log of b. So this is the change of base. So we can just come to our calculator and we can type in the log of 324. Make sure you close that parenthesis, divided by the log of 62. Enter. And you get 1.4. Okay. And hopefully that one's pretty easy. Number 9 is not on there. Skip it. Don't worry about it. Okay, problem number 10. All of this page will be no calculator part. No calculator part. Okay, so this is where we started solving log equations. And remember, we had 3 choices of things to try. We could change them to the same base, or make them into the same base. We could change them from log form to exponential, or exponential to log. And we could take the log of both sides, although we don't normally do that. So on this one, you have 4 to the x plus 1 equals 8 to the x. So these bases, you have an exponent equals an exponent, so we're most likely going to change the bases to be the same. So what base could you turn 4 into? And remember, sometimes you guys change the value of this. You can't change the value of this. 4 is the same as 2 squared, so I did not change the value of this. 4 is the same as 2 squared, so 2 squared equals 2 squared to the x plus 1 equals, okay, well, what can we change the value of 8 to, or what's the same as the value of 8 with the base of 2? Well, that would be 2 to the third to the x, because 8 is the same as 2 to the third. So I have not changed the value of either side of this equation. That's important that you know to do that. Okay, on this one, this 2, you have to distribute that 2. So power over power, you multiply. You get 2 to the 2x plus 2 equals 2 to the 3x. So same bases, you know that 2x plus 2 has to equal 3x. This is a linear equation. Subtract 2x. Sorry guys, I'm working on this slate, doing the best I can here. So we get 2 equals x. And there is your solution, and you could check it and it will work. Okay, how about number 11? Well, we have log form, and it is single log form, which is good. So we're going to change it to exponential form. So we're going to say 4 to the third equals x plus 48. So again, we just swooped 4 to the third equals x plus 48. Well, 4 to the third is 4 times 4 times 4. That's 64. Subtract your 48. And you get 16 equals x. And you could throw 16 back in here and check it, and it would work. Okay. All right, problem number 12. Well, we have the log of x plus the log of x plus 48 equals 2. So I like that the 2's on this side, but we have 2 logs over here, and we need to write this in single log form. So when you are adding, remember the rule says we take these values and we multiply. Excuse me. All right, so we have the log of, and this is going to be x times x plus 48 equals 2. And then remember we distribute in here, so you get the log of x squared plus 48x equals 2. So we just came up here and we just distributed this x. Okay. Well, we are now in single log form, so we're going to change it to exponential form. What is our invisible base? Hopefully you guys remembered the invisible base of the common log is 10. So we can now swoop. And when we swoop, we get 10 squared equals x squared plus 48x. Well, 10 squared is just 100, so we're going to say we have 100 equals x squared plus 48x. This is quadratic, so we got to get this 100 over, so we get 0 equals x squared plus 48x plus 100. Now, remember this is a no calculator part. You could use the quadratic formula, but I think you're going to find tomorrow or when the test is that this is going to be much, much easier if you factor it. So a is 1, quadratic trinomial, life is easy. We can factor this and we say what multiplies to give me 100 and adds to give me 48. Again, what multiplies to give me, oh, this should be a minus. I know you guys are all screaming at me. Sorry. Okay, let me fix this up. Okay, so when we subtracted 100 over, we got minus. Sorry about that. And now what multiplies to give me negative 100 and adds to give me 48? Hopefully that's a little better. So multiplies to give me negative 100, adds to give me positive 48. And hopefully you guys are saying positive 50 and negative 2. Then we can use the zero product property. Set each one of these equal to 0. You guys don't have to show me this work. Or over here you have x minus 2 equals 0. So you get x is negative 50 or x is positive 2. All right, well, we got to go back and remember if we plug these into here, you have to have a positive argument. So if you plug 2 in, you get 2, and here you get 50, and that would work. If you plug negative 50 in, you cannot take the log of a negative number. It does not exist. So we're going to cancel this one out. That does not exist. So the only answer for this problem is 2. Okay, cruising right along here. Number 13, the natural log of x minus the natural log of 7 equals 4. When you have minus, remember you divide these. Now be very careful. I want you guys to remember, because we just talked about the other change of base formula, log of m minus log of n is equal to the log of m over n. The change of base formula that we did earlier, a couple of slides earlier, said log base b of m is equal to the log of m divided by the log of b. Sometimes you guys get these mixed up. Be very, very careful. Change of base, log of m over log of b. This one, when you're subtracting log of m minus log of n, it is the log of this quotient. So do make sure you guys are careful between the difference in these. So this problem is going to follow this top rule. So we know that the natural log of, and you always take this divided by this, so it's going to be x over 7 equals 4. Okay, so we moved it into single log, because we know we can't really solve these log equations at all until we move them into single log form. So we've changed it into single log form, and now we're probably going to want to change it into exponential form. But what's my base here? Because we're going to swoop. But what's my base? Well, natural log, remember, is log base e. So we kind of have an invisible e there. So this is e to the 4th equals x over 7. So we have e to the 4th equals x over 7. Now remember, e to the 4th is a number. This is not a variable. E is a constant, so e to the 4th is a number. And we're trying to get x by itself, so we're going to get rid of this denominator by multiplying both sides by 7. When I do, those cancel. So I have 7 times e to the 4th equals x. So we're going to grab our calculator, and we're just going to do 7 times e to the 4th. And you get 382.19. So 382.19 if you round. And we're done with number 13. Okay, problem number 14. I'm going to tell you right now, there is a problem very similar to number 14 on the test, and every year it seems like it really throws students for a loop, and it really shouldn't. This is designed to be a very, very easy problem. It says the natural log of e to the x over 2. It wants you to simplify this. Well, you can do it one of two ways. You can just reason through it. You can say, what is this equal to? And then you can come down and say, well, the natural log is just log base e of e to the x over 2 equals what? And then you can, this is log form, so you're going to swoop, change it to exponential. So e to the what equals e to the x over 2. Well, you know your exponents would have to be equal, so the value of this is just x over 2. That's one way. Some of you will remember your rule. And your rule says if you have log base b of b to the x, it will always equal x. So some of you will come right here and say, well, the natural log of e is just log base e of e to the x over 2, so it's always going to be x over 2, or whatever that exponent is. So again, you could use either one. Okay, problem number 15. I guess I should kind of go back for 1 second to problem number, I got to find it here, right here. Be careful. This problem here talks about it being an exponential function that decreases. So this is exponential decay. You are using this formula for exponential growth and decay. This problem talks about her investment, and I can't remember on the test if I give you this formula. I don't feel like I do. I'm trying to look right now real quick. But this, what you have to make sure, I'm trying to find it. Oh, I do give you the formula. Okay, so I guess I do give you the formula. Lucky you. But what tells me that I have to use this is that it is compounded continuously. This formula, A equals PE to the RT, tells you compounded continuously. What I struggle with having students do is you guys want to use the continuous compound formula for this one. But this one is exponential growth and decay. It is not a compound continuous formula. So you cannot use A equals PE to the RT on problem number 2. All right, so I know I'm jumping all over the place here. Let's go back to 15. It says Janelle wants to invest $3,000 in an account that earns 3.2% interest. Now, guys, this is 12 years. Remember that rule. You know, even if you have a really good interest rate, it takes about 15 years to double your money. So if you get some huge number here, then you have done something wrong. Okay, A equals PE to the RT power. So we're just going to plug away. What is her final amount? If she invests, remember P is the amount invested or borrowed. It's the principal. So it's 3,000 times E, which is a constant, raised to the RT power. Well, remember that the R has to be a decimal. And 3.2% is 0.032. And then times T, which is 12 years. Now, the biggest mistake that you guys will make on this one is you absolutely have to have parentheses around the outside of both of those because it's raised to this product. It is not raised to this and then multiplied by 12. Okay, so go back to our calculator. We're just going to type in 3,000 E to the 0.032 times 12. Close those parentheses, enter. And this is a reasonable amount that after 12 years we're going to have $4,404, and then money, since this is money, I should always round it to 2 decimal places, so it's going to be 44 cents. And there's your answer. Okay, good old number 16. When you have exponential growth, or half-life problems or half-life problems. I believe, again, I'm going to double check that I give you this formula, but I do not give you, let me double check here, I do not give you what each of those values mean. So I'm just double checking, yep, that formula is on there. So I do give you this formula, but I do not tell you what each piece means. So it looks like the only formula I didn't give you was to problem number 3. Or a 2, the one where Gina bought the car and it decayed. That's the only one I don't give you. All the other ones it looks like I give you. Okay, so I need these 3 things. I need K, I need your equation, and I need your answer. So remember, the first thing we have to do is find K. So we need to find K. And remember, to find K, you use the half-life. So we're going to use the half-life to find the value of K. So again, our formula is n sub t equals n sub 0 e to the negative k t power. And it says that you have a 650 milligram sample and that the half-life is 28 days. It tells you right here, half-life is 28 days. So remember, we could do 2 different things here. We could say we started with 650 milligrams. Half of 650, remember, is 325, so you could put that over here. E to the negative k times 28. Okay, and then we would have to divide by 650, and a lot of you will skip this part because you know in half-life, if you have your original amount here and half of it here, every time you divide, you will get 1/2 equals e to the negative k and then the time of your half-life. So in this case, negative 28k. All right, so this is an exponential function. We need to change it to log. So we're going to write log, and we're got to swoop backwards here because our exponent's over here. So log base e of 1/2. So log base e of 1/2 equals negative 28k. Well, remember, log base e is the natural log of 1/2 equals negative 28k. Divide by negative 28. And k is equal to, well, we're going to go to our calculator. And we're going to go natural log. 0.5 divided by negative 28. Enter. Okay. So you should see that you get approximately 0.02476. Okay. So up here, K is 0.02476. Now I'm going to be very, very lenient on this for rounding since I wasn't here. So just know that I'm going to be pretty lenient on that. Okay, so what is the general equation? Well, the general equation for this decay is N of T equals, what was the original amount? The original amount was 650. E to the negative K, so that's negative 0.02476. And this is the equation I would like on your answer blank. Okay? So that will go up here. All right, now the last part. This is a long, big problem. The last part finally says, how long does it take it to decay to 200 milligrams? Well, that's our final amount, so we just plug it into our final amount. So we had 200 milligrams is what we want to know. How long does it take us to get there? We started with 650. E to the negative, we know the constant is 0.02476 T. And to solve this, we're going to start by dividing each side by 650. And when we do, I'm going to go ahead and leave this as 200 over 650 equals E to the negative 0.02476 T. And then in order to change this to log form, we're going to swoop. So it's again log base E, which I'm just going to say, hey, we know what log base E is, so I'm going to erase that. It's not log base E, it's the natural log, log base E, natural log of this, which is 200 over 650 equals negative 0.02476 T. Okay, still trying to get T by itself. So we are going to divide both sides by this. Now remember, we're going to use our calculators on this because I kind of rounded this a little bit. And when I do, I get T equals. So here's the way I'm going to type this in my calculator. I have this last answer. This is my K value up there. So I'm going to do the natural log of 200 divided by 650. Close your parentheses. Divided by negative second answer. And when I hit enter, I get this. So I have 47.6, and the units for this was the time was days. So it will take 47.6 days for this to decay to 200 milligrams. Okay. We're getting there. That was probably a tough problem. Okay, next ones. These are going to be graphed on your graphing calculator if you would like, but there's a lot of things that we need to know and some things I'm really going to watch for. Okay, you need to remember the difference between a log and an exponential function. Remember, the parent log function goes like this. The parent log function has an asymptote at x equals 0. The parent exponential function goes like this. It has an asymptote, at y equals 0. Okay, so kind of keep that in mind. You need to know that. You need to know the difference between exponential and logarithmic and which ones have which asymptotes. Okay, so this one, let's go ahead and talk about it. It says graph the function, describe the asymptote, or give me the equation of the asymptote. By describe the asymptote, we want the equation of the asymptote. and then tell me how it's transformed. Sometimes I like to start with how is it transformed first. So I'm looking at this. The parent function, remember the parent function for this would be f of x equals the log of x. So this is a log function, so we know it's going to go like this, and we know it's going to have a starting asymptote right on that y-axis. And let's see what happens. Well, we have a 2 on the outside. So remember, if everything is being multiplied by 2, we have a vertical stretch by 2. Okay? And then we also know if we have plus 1/2 in here, this is being shifted. Remember, plus is opposite of what you think. It's going to go to the left 1/2. So my asymptote was right here for the parent function on that y-axis. But it got shifted to the left 1/2. Now it's kind of hard because a half is kind of small. So your asymptote is now right here. So you need to tell me that the asymptote now has an equation of x equals, because it crosses the x-axis, it's a vertical line, and it crosses the x-axis at negative 1/2 because it went left 1/2. So we have left 1/2, there's my asymptote, here's my shifts that I explained, and the last thing I have to do is graph it. So you could at this point grab your calculator if you would choose, and go ahead and type in 2 log of x plus 1/2. Oh, I forgot to do zoom 6. Zoom 6. Okay. Now be careful. The graph does not stop here, and I will look for that. If you have a graph stopping, that tells me that you don't understand what's happening to this graph. Okay, what's happening to this graph is it's getting really close to negative 1/2, but it never gets there. Why does your calculator stop? Well, because the pixels it can't get any closer because it actually thinks it's negative 1/2. So you need to recognize, and if you need to look at the table of values, you can look at the table of values, but I want you to know that this graph comes in like this and curves down and gets super close, but never crosses this asymptote. So I need to see that you know that you know it keeps going. It does not stop. Okay? All right, well, once again, this one, let's think about the parent function. The parent function for this one would be f of x equals 1.5 to the x. So this is an exponential growth. So we know it's going to go like this, and our asymptote's going to start right here at y equals 0. Well, I like to talk about what's happening to these graphs first. Well, the whole thing is being multiplied by 3/5. So that means I have a vertical compression by 3/5. The whole thing is being multiplied by a number less than 1. Then I also have this 6 up here, and that you need to be careful. Remember, if it's with the x, it's a horizontal stretch or compression. And remember that horizontal stretches and compressions are always the reciprocal of this. So it's really by a factor of 1/6. Well, if it's 1/6, we know that it is a horizontal compression by 1/6. So I need to see that you know it's a horizontal compression and what the factor is, and a vertical compression and what the factor is. So here's your shifts. So ask yourself, did this change my asymptote at all? My asymptote was right here on the x-axis. Well, the only thing that's going to affect my asymptote is if it shifts up or down. If it shifts up or down, then it affects it. But it doesn't. So my asymptote will stay right here on that x-axis. So my asymptote is at y equals 0. And then you could graph it on your calculator, or really the one thing I'm going to check for this one, what's your y-intercept? It's at 3/5, so you know it's down here. And you know that it approaches that line and gets closer and closer, closer, but never gets there. Okay? All right, almost done. Last couple. This next one here is no calculator again. And it says, if the natural log of x, so my parent function for this one is f of x equals the natural log of x. There's your parent function. And it says it is being shifted, okay, to the left 2, so it's going left 2 and up 1. And then it's being vertically stretched by 3. So then it's being vertically stretched by 3. So you have 3 things happening here. Okay, well first, if it's being going to the left 3, remember my new function, g of x, would be the natural log. Well, if it's left 3, it's left 2, it's x plus 2, because left is plus. So there's left 2. Now you're going up 1, so it's the natural log of x plus 2, and now if you go up 1, you just add 1. And now if you do a vertical stretch, remember that it's going to be multiplied by all of this. You cannot just put it out here, because it's going to the natural log of x plus 2 and to the 1. So I will allow you to just write this 3 times, parentheses, the natural log of x plus 2 plus 1. And this is your final answer. If you wanted to distribute out that 3, you could. You would have 3 times the natural log of x plus 2 plus 3. So I would accept that as well. Okay. Determine whether this is an exponential function. Well, remember, to determine if it's an exponential function, you need to see if there's a common ratio. So you're going to divide. Again, we picked numbers that were pretty easy on the test. So you're going to divide, and this is easy. You're going to divide 48 by 24. So when you divide 48 by 24, you get 2. 24 divided by 12, 2. 12 divided by 6, 2. 6 divided by 3, oops, my mind was thinking the next problem. Okay, so 12 divided by 6 was 2. 6 divided by 3 is 2. 3 divided by 1.5 is 2. So is this an exponential function? Yes, it's exponential. So yes, it is exponential. And then it says if it's exponential, what's the ratio? Well, the ratio is 2. So I will look for that and that you knew that it was exponential. Okay? Last one. All right. Again, remember that I will tell you on the test, as you found in your homework, that it says which type of regression we want you to run. So it will either ask you for a logarithmic regression or an exponential regression. Okay? The table gives the population size for a flock of birds over the last 55 years. So here's the data collected, here's the population. So, calculator, stat, edit, clear your lists. So stat, edit, clear your lists. And then enter your data. So we have 5, 22, 40, 57. Over here we have 18, 22, 85, 185. Double check I got everything entered right. 5, 22, 4, okay, 18, 22, 85, 185. Okay, so once you enter your data, we're going to go to Stat, Calc, and this one wants an exponential regression, so I'm going to go to 0 or 10, which is exponential regression, enter, enter. And the exponential model says it's y equal, oops, sorry there, let me get this back to pens. Okay, It says it's y equals a times b to the x power. Well, here's your a, so you have y equals 11.26 times 1.05, because I rounded, all to the x power. So here's your model, because it says you write the model. So here's the model. That's part 1. Okay. Now it says in part 2, use the model to predict the population's 75 years since the data was collected. So now they're saying x is 75. Now, we could put x to 75 here, but I am not going to allow you to do that because these are rounded numbers. And it wasn't exactly 11.26 and exactly 1.05. It was these big, long decimals. So we are going to use our calculator to do this. Okay. And we're going to go, remember, into y equals, clear this up. Now we're doing a regression, so you got to turn your plots back on. Okay, plots back on. How do I paste this regression here? I go to vars, statistics, equation, enter. I'm going to go zoom, and I'm going to go to 9 for stat. It wants to know in 75 years, so I could go second, calc, value, and it's saying, what do you want me to let x be? Well, I want you to let x be 75. And it says invalid. Well, why does it say invalid? It says invalid because remember, if you go to your window, your x max is 62, and you're trying to tell it to calculate at 75. So we're going to come down here, and we got to change that to something bigger than 75. And I'm going to change my scale because that's just way too many tick marks. Tens. Probably should have left my window up there for you to see. I'll go back and grab it 1 second here. Okay, so window, and here. Okay, so then, now that I've done this, now I can go back to my graph. Now I can go second, calc, value. It's saying, what do you want me to let x be? I want it to be 75 years. And when you hit enter, you will see in 75 years the population was. Now you can't have a fraction of a bird, and I know we could argue whether you round up or down because technically you wouldn't have that many birds in that day, or in that year, but 413, 414, somewhere in there would be acceptable. So, okay, I think that's it. I hope you guys are doing well and feel ready for this test. This review truly covers absolutely everything that's on there. Remember, if you missed school for some reason, you really need to try to see about getting these tests done before break. And we'll go from there. So I hope you guys are having a wonderful week. I'm sure I miss you dearly, and we'll see you soon.